Good morning, students. Myself, Dr. Ragasudha, Head and Assistant Professor, Department of Microbiology, Government City College, Hyderabad, is here to discuss on penicillin production. Penicillins are a group of antibacterial antibiotics produced by the fungus Penicillium species. Penicillin is produced by the fungus Penicillium chrysogenum and Penicillium notatum. Penicillin producing bacterium was first identified by Alexander Fleming in 1926. The penicillin was discovered, named, and described by Alexander Fleming in 1929. It was the first antibiotic to produced in large scale during World War II. However, penicillin could not extract enough penicillin from the mold to use for the treatment of patients. In 1938, Howard Florey, an Australian microbiologist, Ernst Chen, a German chemist, and others at Oxford University pioneered the production of penicillin for human treatment. But they had to depend on pharmaceutical companies in US to produce penicillin in a large scale. Penicillin was first released for widespread use in early 1940s and it saved many lives during World War II. It was credited with saving lives of 10 to 15% of all World War II casualties. Penicillin has a bactericidal action. It inhibits the synthesis of the cell wall of the bacteria. It is an effective agent against Staphylococci, Streptococci, Pneumococci, Meningococci, and some other bacteria. Penicillin is a secondary metabolite. Primary metabolites are the metabolites of energy production for the cell and for its own biosynthesis. In aerobic organisms like Penicillium chrysogenum, it involves the conversion of sugar such as glucose to pyruvic acid and producing energy. Whereas secondary metabolites regards the production of metabolites that are not used in energy production. These metabolites are being utilized as a defense mechanism against other microorganisms in the environment. For industrial production of penicillin, secondary metabolites are only produced in times of stress when resources are low and the organism must produce these compounds to kill off its competitors to allow it to survive. It is these conditions that we wish to duplicate in the industry in order to achieve the maximum amount of the product. Penicillin is commercially produced in the industry by culturing the fungus Penicillium chrysogenum and Penicillium notatum. The fungus can be cultured in two methods, namely surface culture method and submerged culture method. In surface culture method, the fungus is cultured on the surface of a liquid medium without agitation. After an appropriate incubation period, the penicillin is extracted from the medium. This is an old method. Whereas in submerged culture method, the fungus is grown in the liquid medium which is vigorously aerated and agitated. After an appropriate incubation period, the penicillin is separated from the medium. Today, penicillin is produced by submerged culture method. In the industry, the fermentation unit of penicillin production consists of the following main components, like it comprises of a mixing tank where all the ingredients are mixed and later sterilized, followed by it consists of a seed tank where the inoculum prepared inoculum is added into the fermenter. The next one is a fermenter and it consists of a recovery tank. Penicillin production in industry is carried out in three stages. The first stage is preparation of media, second fermentation, third is recovery of penicillin. Stage 1, preparation of inoculum. The inoculation media comprises of corn strip liquor, glucose, phenylistic acid, calcium carbonate, sodium hydrogen phosphate with a pH of 6.5, temperature 20 to 24 degrees centigrade and with a time scale of 24 to 48 hours. For inoculation preparation, the spores of penicillium from heavily sporulated working stocks are suspended in water or non-toxic wetting agents such as sodium sulfonate in 1 is to 10,000 ratio. The spores are then added to flask containing wheat bran and nutrient solutions for heavy sporulation and incubated for 5 to 7 days at 24 degrees centigrade. These spores are then transferred to a seed tank and incubated for 24 to 48 hours at 24 degrees centigrade with aeration and agitation for sufficient mycelial growth. This mycelium, the obtained mycelium can be used for production fermenter. The second stage is fermentation. Here, the production media comprises of again corn steep liquor. It consists of lactose in addition to inoculation media, then glucose, phenylacetic acid, calcium carbonate, sodium hydrogen phosphate with a pH of 6.5 and temperature 20 to 24 degrees centigrade. And the time scale is 7 days. The method used is either fed batch culture method or batch culture method. The fermenter used is stirred tank or airlift tank fermenter. The pH is set at 5.5 to 6, which may be increased up to 7 to 7.5 due to liberation of ammonia gas and consumption of lactic acid. If the pH is 8 or more than 8, then calcium carbonate or magnesium carbonate or phosphate buffers are added to decrease the pH levels, because when the pH is above 8, the production of penicillin will be stopped. The temperature is maintained at 25 to 27 degrees centigrade. Aeration 0.5 to 1 ppm, initially more, later less oxygen. Agitation is 120 to 150 rpm. Time is 3 to 5 days. And antifoaming agents like edible oil of 0.25% has been added. The final stage is recovery. Harvest broth from fermentation tank by filtration method or centrifugation method. If it is filtration method, rotary vacuum filtration method is used. The filtrate is chilled at 5 to 10 degrees centigrade because penicillin is highly reactive and destroyed by alkali and enzymes. Acidify the filtrate at pH 2 to 2.5 with sulfuric acid to convert penicillin to its anionic form. Extract the penicillin from aqueous filtrate into butyl acetate or amyl acetate at this very low pH as soon as possible in centrifugal counter current extractor, and discard the aqueous fraction. Allow the organic solvent to pass through charcoal to remove impurities and extract penicillin from butyl acetate to 2% aqueous phosphate buffer at pH 7.5. Acidify the aqueous fraction to pH 2 to 2.5 with mineral oil and re-extract penicillin into fresh butyl acetate. Add potassium acetate to the solvent extract in a crystallization tank to crystallize as potassium salt. Recover the crystals in filter centrifuge. Yield. At the end of World War II, penicillin was first made using the fungus Penicillium notatum, which produced an yield of about 1 mg per dm3. Today, using a different species known as Penicillium chrysogenum and better extraction procedures, the yield is 50 mg per dm3. Biotransformation of antibiotics. Biotransformation is routinely used for commercial production of several useful antibiotics. Thus, penicillin can be of natural, like Penicillium G form is a natural penicillin, which is also known as benzyl penicillin. The other forms of penicillin are semi-synthetic penicillins, and cephalosporins, which are produced by chemical modification of the penicillin nucleus called 6-amino-penicillinic acid. The penicillin nucleus is produced by microbial deacylation of naturally produced penicillin G and penicillin V. This is the general structure of penicillin, which comprises of beta-lactam ring, thiazolidine ring, and a side chain known as acyl side chain. The nucleus of all types of penicillins has the same structure, but the side chain called R, it differs from one penicillin type to another penicillin type. So this is the process of biotransformation of penicillin G and penicillin V by biotransformation by deacylation process. 6-amino penicillinic acid is produced, which is chemically transformed into a semi-synthetic penicillins or cephalosporins. So these are the different structures of penicillin. The first one is penicillin G or benzyl penicillin. Second one is penicillin X, which is known as para-hydroxybenzyl penicillin. The third one is penicillin K, also known as heptyl penicillin. Fourth one is penicillin F, known as N-pentenyl penicillin, and so on. Penicillin today, it is still the most widely used antibiotic, still the drug of choice to treat many bacterial infections. Scientists have continued to improve the yield of the drug. Present-day strains of Penicillium chrysogenium are biochemical mutants that produce 10,000 times more penicillin than Fleming's original isolate. Thank you.